Hello everybody, my name is Marco Bassignana and welcome to this new Robox video. Today we are talking about RPL, which is the robot programming language. First of all, let's open the manual and let's see some information about this. Now here we have this PDF. I'm quite sure you may also find it on the website, and if you don't find it, you may easily ask for this to your contact in Robox SPA. So now let's make it widescreen, that's better. And here we have a summary of the kind of data we have. And then here we go down, we can see some of the functions. Those, for example, are functions for vectors. And here there are other functions for some complex data, other functions, and so on. And here below we can just see more and more things about data, how to make things, how to write programs, and almost something about the kinematics that you can do. And here some review of the revision history of all the RPL language. First of all, let's talk about the RPL and let's say what's that. So let's open RDE and let's, for example, open a workspace. Okay, here I'm lucky, I already have this kind of project. Okay, so much stuff, we do not care. Let's clear the screen. And here, let's go to the configuration. As you can see here on the right, we have a robot, an anthropomorphous robot, 6 axes. And here in the RT project window, we can see that this anthropomorphous robot has got 6 axes. And as always, we have a power set controlling the power of the axis, and we have a set of axes, the axis group connected to the power set and having the Cartesian model of the anthropomorphous robot we would like to control. Together with this, since this is a special project, here we have some other OB we are playing, some XPL API, RPL manager, something for the I/O processor, and general. Together with this, let's just take a quick look at the Ethercat, and we can see that all the Ethercat is just using this EC2A. EC2A, maybe you already know, it's some of the Robox provided drive. As you can see, an EC2A, EC2B is a drive which can control 6 axes. You can see here we have 6 CSP axes, and so here at the end we can take a look at the long list of the I/O, and so we know that this is what we need to control more axes. So just one device is able to control 6 axes, because for example here you can see in the field bus ETH1 EC2A, and inside the ETH1 EC2A we can choose, for example, axis 1 here for station 1. If, for example, I ask station 2, I can see EC2A axis 2, and so on and so on. This means that only this kind of hardware provided by Robox SPA is able to let you control the power to your anthropomorphous 6-axis robot. Now, in order to begin talking about the software part of this, let's start taking a little look deeper at XPL and RPL. First of all, we see here this kind of OB, which is something already predefined. You may just include it in your project and then you can use it. Normally for this kind of project, you don't need to make all of these things I'm going to say right now, but you had better knowing them for your personal knowledge, and also because maybe you are having a predefined project, but maybe you can have nothing, and so you will need to do this. First of all, XPL is the special environment for programming languages. This is a high-level programming that Robox SPA is giving you to play with some high-level languages. We have made some machines like CNC, laser cutting machines, and glue machines and many others using the XPL, which is an interpreter of this high-level code. The high-level code used by that kind of machine is just a G-code. A G-code which is powered and improved with some strong and evolved command we may use to make some more developed functions, such as if, for cycles, subroutine calls, jump, and I/O reading and setting. Because all of this, if you would like to make that kind of machine, please contact Robox SPA to get more information about this. Just keep in mind that XPL is an interpreter, and so more kind of high-level languages may be used, and the XPL will make the interpreter for them to convert their commands to the RPE environment. In this case, we have created a robotics program, which in fact is called RPL. And so the XPL is the interpreter, as always, and the language that today we use is exactly RPL, which is the robot programming language that, as I already said before, it's the one you can know more reading the manual. Now, apart from the set of axes here and the power set and this I/O and other axes, we would like to make some other settings. First, let's come here in general. Let's go in storage and please take a look to these last two parts. We will need some global variables area and some XPL structures that have to be here we need to allocate some memory, and so here you can see we have 1024 and 65,000 and so on byte that we have to allocate to be allowed to use this kind of evolved programs. And together with this, no other base configuration should be requested. Here in the main configuration of your program, you may see in the configuration here XPL, you may enable the generation of the XPL configuration file, and you will need to add a /XPL folder in your flash files. Later we are going to see it. Here below you may include an XPL environment. You must do it, so right click, new, and here you see XPL environment. Create one of these and you will have this one. So give it a name and connect it to your axis group. You can write here the stop time expressed in seconds. Here you may have some customized definitions, and most important of everything, here in the modules, you may add some of the already predefined modules. For example, a base shared module is something already handling some kind of variables like speed and joint radius for connected motions and something like this. Here it's the tool handling, and here that's something used related to the user frame you may would like your robot to be related to. If you want to add other ones, just click here in the insert of new XPL modules, and here you will see all the library provided by Robox environment, and here you may play something, for example, for auxiliary axes, collision detections, or for example some other stuff. Here there is some tuning of some parameters and so on. Some other modules, remote I/O, and so on. Now, apart from this, I would confirm that part, I'm not touching this, and let's take a look at the flash files. We are used to deal with F8, which is the system folder, FA, which is the main program folder for the user application, and the OB folder, which is storing the object blocks. Here you can see many object blocks we would like to play, and that's because they are already set in our project. Some of the ones we already include here already have the inclusions of other ones, and that's the reason why here we can see so many ones. Together with them, we will need also to include some other stuff. Here you can see this application, here we have application and I/O. This is to have the I/O configuration. If I open that kind of XML file here, I see actually nothing useful, but here that's just something we would like to have in order to play with I/O. Here something for auxiliary parameters. And so let's see, here we need application auxiliary axis. You have to write these folders. As I said before, maybe you will have an already developed project provided to you by Robox staff while you would like to start an XPL or RPL program. But in case you do not have, please do not forget to do this kind of folders and to include that kind of files. As you can see, the icon is just a white paper. So since there is not the blue little icon here in the top left corner, this means you have to add them on your own. And this means you need to have that kind of files inside the folder of your RDE workspace. Together with this, we can go down. Here we have the XPL configuration that we enabled here, as you remember, just a few time ago we checked this. You have to enable that part. And together with this, we said there is no other important settings. In the log, okay, that's something just for the user log. Here this is something for the mod. Maybe it's not something you would need so much. And so it's not necessary, these two are not compulsory. But here we have the point library, the plib, and here we have, let's say, mainly the XPL folder, that is the one defined in the settings here. And in fact, you can see here we will have 3 system files, so they have the white icon together with the blue square. And finally, inside the RPL folder, you will find the RPL files you already programmed, and maybe some ones you would like already to store inside the memory of your system. Otherwise, you may just download them from the ones you have developed inside your RP2 controller. Now, for example, you can see all the files have an extension which is .xpl. As you can read here, the structure of this XPL is almost a special version of XML programming language. So keep just looking at this and keep in mind that's an XML which is not so suitable to be read just thanks to a TXT viewer or TXT editor like the Notepad. The best way to see them is to use the integrated editor that you will find in the HMI. Now, first of all, before loading everything online, let's go again in configuration. And let's check, okay, the Robox controller today is an RP0, and it's exactly, that's the controller I have today. Now I do not have this Axioline module, but I do not care too much because I will not load the RHWCFG. While I will do a rebuild in order to put the project on my RP0 controller, I will never check the F8. That's because on one side I do not want to load inside an RHW file which is storing some information that's not true. That's because I'm playing with my Robox controller directly on my desk and I have no Axioline module connected to it. If I load this kind of RHW, I would see some useless and very annoying alarms telling me that it was expected to see that kind of Axioline module, but actually I do not have. So I just prefer to keep inside the RHW I already have, and that's already a good one for simulation. Together with this, I also do not want to make the rebuild to the F8 because otherwise I would erase all the files inside. And as you already know, here inside we have the RTE, which is the operating system, and we also need the RPE, which is the robot the Robox Path Executor, which is the firmware for higher level of Robox programming in order to control robots and a set of axes. And today we are talking about the third level of our programming layers, which is the XPL. This means that level 0 is the RTE, and maybe we have already learned how to write the R3 programs and the object block in C++ in order to play your program and control your axes. You may just use the first level, so the R3 language and all the functionalities of RDE and R3 language in order to control your machines. But for some more developed structure, like mainly robot, like Anthropomorphous, Cartesians, Scara, Delta, and so on, or for other some special ones you may define on your own, you would like to play the axis group. And so you may already have seen the videos on YouTube about R3 and RPE. Together, as I said, we got to the third level, which is the RPL. That's one of the languages of the XPL, and since it is a higher level language, this is very easy and very quick to write for the user, very useful for some robotic applications, but keep in mind that since it is a high-level programming, the possibilities you have will be less than the ones of a structured test that you may write as you want. So the detail of the control you will have is less, but the speed and the possibilities in order to make some easy-to-play program will be much, much higher. Now, together with this, as I said, since we have 3 levels of programming, and so we are using 3 levels of firmware. The RTE, that we can see fdir in /f8, that's the system folder. Here we have the RTE, which is the standard operating system. This is always compulsory in our Robox controller. Here we have RP, the Robox Path Executor. And that's the one in order to control the axis group. And finally, now today I already loaded here the XPL. If you want to find the XPL, you can download it. I'm quite sure it's inside the R setup. Let's take a look. I come here, I open R setup. And here let's open the catalog, let's see what's available online. If I want to see the news, for example, I can find net control, RT BIOS, RT firmware. Let's get and take a look here below. RT, RP, no, sorry, I'm not finding it. So sadly it's not here. In this case I'm quite sure you will need to ask to have a copy of XPL to Robox staff. If you need it, you may write to Robox, you can write to sales@robox.it, or maybe you can just take a look at the website and check the firmware. And RT, RP, BIOS, IMD, RTM, no, I apologize, here it's not available. So, in order to get the XPL, you may find an updated version just asking it to us. You may write an email and request for it, but as I said before, it's mainly it's likely that while you would like to play that kind of things, you will already be provided with a fully working workspace already from Robox SPA. So now let's say here I will do I don't do the rebuild because I have already done before. And now let's take a look also at programs. Now here there are many object blocks, but do not care about them. They are system ones, you will not be provided with them. That's because they are some Robox private object blocks, and so you will have one rule and one task. As you know, since we are playing the XPL, which is something higher level and speaking with RPE, so we do not need to play the rule. You already know from previous videos that playing RPE just needs a task 1. But if we open the task 1, we see that's almost an empty task. There is just a startup calling this first boot in which there is nothing. And finally, inside the main loop, we have a restart point, and here we just have some junk code just reading the current time. I make it bigger. Here you can see we are just reading a timer and we are just making a wait, a DWL, which means wait some time and nothing more. This means that the task is free for you. In the same way, in case you open the rule, you can see that here we just place some variables. In the rule init there is nothing, just the definition of the prologue. And here inside the prologue there is just the call for this handler of power information of the EC2A, and this handler power information, it's the only function here in rules where we are just reading the current, and then we are calculating the torque, and then from the torque we calculate the power and the total power. That's just some data we are playing in this example. You may cancel all of these and write everything you would like to do. So you can use some auxiliary axes you can define in your project and you can load inside, or you can also play some other kind of code in order to handle some I/O or anything else you would like to do. For example, some other communication, some other device, some TCP/IP or Modbus device may be connected to your system. And so here in the task and the rule you may write, sorry, not this rule. In this rule and in this task you may write the code you need. Now, I already made the reboot, the device has already been booted, so let's take a look at the M report to check that everything is good. So let's clear the screen, let's make M report -A. I play with the quick commands of my shell, but remember that if you want to clear the screen you just call it clear, and then you can write M report space -A, and in this way you will have the report of all the system. And now let's take just a fast look at it. Here we talk about the FAT32 of the SD card. Here we check something. Here there is the net control. Sadly, my controller is not is not having it working well, but we do not care too much. Then Ethercat, but okay, that's something we do not care too much because it's simulated. Something related to the field bus connection, okay. Something more related to our clock, to our net control, the product, and so on. Here we start the RTE operating system. Here we read my license inside the system. The override file that I put inside, here you can see it here. That's not selected, but I already loaded it on my own in order to see it and write inside that we would like the axis required. You can see in this line, I take out the mouse because it's not reading so well. You can see the yellow written line, axis emulation required 0x3f. That's because I would like the emulation of all the 6 axes of my robot. You can see here 1, 2, 3, 4, 5, 6 axes in hexadecimal. The bit mask of this is 0x3f. Then we go forward, we have just something again for global variables. And then we have some other stuff about alarm history, settings, Ethercat that of course is just saying a lot of lies because it's emulated. Something retentive for the quotes of the transducers of my 6 axes, again so many lies because they are emulated. Now we start the RP and here the XPL. Alright, then some other stuff for the connection, communication, again lies over Ethercat. And here we begin loading some of the very nice object blocks already provided by our project, so we do not care about them. The RPL manager object block, which is the main one ruling on the RPL language. Some other things we would like to see, and here we begin with task 1 and the rule that we just saw they are empty. Modbus, which is something we do not care too much in this case. And here again some XPL, startup, and now finally, after some other things we do not care too much about the XPL, we are ready to play. I can say ALS, and so I see we have an alarm on axis emulation active. Okay, we have an emergency stop because we have the red button pressed, and here we have this very interesting alarm, which is TPU cable disconnected. That's because the way we have to work with RPL is using an HMI. So while in all the others lower level programming styles of Robox like RTE or RPE, you just need your RDE development environment and you can just write your task and play with it. Now the system handling and the writing of the program is not related to RDE. I'm using RDE just to let you see and to debug a little. I can now show to you the real device. While you buy a system and you would like to use the XPL, you need to use either the TPU or some other kind of physical HMI, and on this you need to play the TPU. The TPU is our HMI program, and inside it we have the handling of all the RPL. Now, since I do not want to play the real HMI, also because I do not have any hardware, I can play it virtual GPU in my PC. First of all, I go in the user folder, and here there is an ip.def. I can press it, and I can see the value of the current IP address of my controller. 192.168.112. Let's take a look. Let's ping 192.168.112. Very well, I can read it. Okay, so the IP is correct. And so that's what we really need. And then I can go in the virtual TPU bin, and here I make it start. As you can see, this is an RTM developed program. So, as you know, this is the Robox display tool executor, which is the executor of our HMI. Here, the program for the HMI is already developed, and today I apologize, but I will play an HMI which is related to some of our main customers, which is... no, there is nothing. Excellent. Very well. So, this HMI is clean, there is no information about anyone, and here we need the administrator password. Here I will write it, I will log in. Seems okay. No need, I'm already administrator, and here I can go to see the files. Alright, here we can see the files I already have in my system. The files I can read are the ones stored here in the /RPL folder. So all of them here, as you can see, are the files. It's the same list I can see here. Alright, here I can also take a look at the monitor, and inside the monitor I can see, for example, something due to the drive, and here if you want, only if you know the master password, you will be allowed to set the zeros of your axis. Now I already have the zeros set, of course, because it's just a simulation, and so I have no need. Otherwise, in case you have a real machine, you can see something about the field bus, something about the I/O, and mainly we every time can see something about the position. About the anthropomorphous robot, we can see all the joint positions in degrees and the Cartesian positions called robot in millimeters and degrees, of course, for rotations. Now, if I play here the robot, we can see it here. Okay. Now, let's take a look. First page, as I said, is login. Here we choose the file. Program, we will see the program while we will do it. And here then we can see something about position. Now, let's go again in position and let's start to go on power. First, let's press F1 to see again the alarm window. Here we have axis emulation active, okay. The emergency TPU, the emergency stop, that means the red button. Now, since we are simulating, I will press play here and I will press the 2 emergency. So to take them out. And the TPU disconnected was stated because this RTM TPU was not connected. In case you have to develop your own HMI, you will be allowed by pressing here, and here you may see some other functions. Here this menu is letting you using some settings like language settings and IP address. I can see it here. This is the IP address. Here we have the language and something else. But remember that this is some expert users part. And all of the other parts are also something related to tools or user frames, some input-output settings, and this is just some version information. Let's say that if you want to improve your HMI, you will need the main project, and from main project you may add more pages, and they will have some buttons that could be listed here. In order to do this, please contact Robox in order to know how. Now, let's go again to these settings. I actually wanted to close it, but I cannot. So let's go to monitor. Now, since I pressed the emergencies and I already solved all the alarms, I have this green button. I can show it to you again. Let's kill the emergency. Let's come here, and the button is red. And of course, we have the red LED of error because of the alarm. I can press it, and now you see the button is green, but we still have the error. I will press this button to solve the alarm. Some of the most updated TPUs do not have these 2 buttons to close and solve, but just one of the 2 that will make both the fix. So just press it sometimes in order to be sure to reset all the alarms and go to the normal situation. Now, as we know, we can read here the operating mode of our robot. And the operating mode is now missing power, which is mode number 1. As you already know, from the operating modes of the RPE, we can have the execution and manual. Now, if you don't know RPE behavior, please take a look at RPE video already shared on YouTube by the Robox SPA channel inside the learning and training channel. Now, for example, in this case, we would like to play the dead man. The dead man normally is something you can see here. I can show to you catalog, products. Let's go to the HMI. And here, let's play, let's see. Normally, the Rig 8 of Robox is the kind of HMI we use for robots. That's because we have all of these buttons here, both on the right side, and here below you see the F button plus some others. All the same are listed here in this virtual GPU. And together with this, we have the red button. Of course, now I do not have, and so that's the reason why I have to play with these buttons. And finally, we have here below this yellow button, which is a dead man. While we want to play manual mode, we will need to press the dead man. Now, normally I may click on here, but now the input is not so nice, so I already put it here. And now we are in manual mode. And you can see here this S has become green. Now we are in manual slow. The TPU has 3 operating modes: manual slow, manual full, and automatic. Now we are in manual slow, and in case you use a real TPU, you can see here there is a key. In some older models, instead of a key, there is just a selector, a 3-state selector. Now the selector is in the middle, and so we are in manual slow. In case we go to the right part, sorry, we are in automatic. In case we go to the left part, we go to the manual full. They are both manual modes, but normally the manual full is something you would like to select in order to allow the feed rate of your machine to go more than 20%. Otherwise, if you just stay in the normal manual slow, the feed rate will be limited. Now in manual full I can, for example, say 75%, but if I take out the left key, I will go back to manual slow and the feed rate will automatically be limited at 20%. So, I suggest you always to remain in manual slow while you are developing a new program. In this case, while you will play it, the robot will move very slow, and in case of mistake, in case of error, in case the robot makes something very wrong, it will be so slow you will have time to press the emergency button, or just to press the stop and stop its motion. Now here you may see also the user frame and the tool which is used right now. If you want to set the tool on the user frame, remember you can play them here, for example. Here you can set the tool. You can, for example, come in tool 1 and modify and just say here, I would like to have 100 millimeters in X. Let's save. Let's return. And now let's activate. Alright, now my robot will have this kind of tool. If I go again in position, I can see that now I have tool 1 and the local world object. Now I can see this kind of X, but okay, that's not something so important. Here we can see the tool, and now since we are on power, we can try to move. You can watch at the robot here shown in the 3D panel. Now I will move J1. Oh, sorry, I'm not in power because I have changed it so many times. Now every time you change, you must give power again. So I press again the dead man, and now I can press J1. You can see I'm in manual slow, and here you can see the robot moving. J2, minus, and plus. In the real TPU, of course, you will need to play the physical buttons on the right side in order to do this kind of motion. J3. Okay, and let's say that thanks to this we can rotate and move all the axes of the robot. J4, J5, and finally we can move also J6, which is the rotation of the wrist. Alright, in case, as I said before, we go to the K left, we go to the manual full, I can do the same things, but I can go much faster. So you can see that's more dangerous. But if you are skilled, if you know what you are doing, you may move things in an easier way. Alright, now let's go and let's create our first RPL program. Oh no, before of this, let's see other things. Here we can have the fast slow part, so in slow, I will just move at 10% of the feed rate. So you can see it's moving like this, and now it's faster. In the grid movement, we will have to set the sides. I can set 10, for example, and now while moving, every step will move by 10. You can see now the J1 is 0, now is 10, 20, 30, and so on. Now, in case we would like to move in a different way, we can just click here, and instead of jog, we may use, for example, robot, which is the Cartesian movement, tool, which is a Cartesian, we refer to the tool reference frame, and some other user frame. Let's take, for example, robot, and now let's move, for example, plus will move along the x-axis, which is the red one, as you can see. And now it's grid movement, so let's take it out. Plus and minus x, plus and minus y. and then plus and minus z, plus z, minus z. You can see the red, green, and blue, so the RGB coordinate system, which are x, y, and z. So now let's go again to jog, and let's go to make a new file. Now let's make new file, and let's write demo RPL, and let's call it, okay, today is 2023-11, no, today is December 1st. All right. Very nice. Here we are beginning the program, and so here we may see we have some things. Okay, here in the code we will just write the code. If we need to write some subroutines, we will list them in this point. In the log, while we will play the program, in case we have some error, here in the log we may know more information. And edit is just something we would like to enable while we are here. And finally, if we would like to define some variables, here we have the variable part. Here on the right, we may choose among main and subroutines. Now I do not have any subroutines, so there is only main. Here I can choose between robot or other things, but now I only have that kind of axis group. In case I have more ones, I would be allowed to play. And now let's press edit again. And here you can see we already have some standard commands we may would like to use. And while we are happy of what we have done, we can save the program. Now, let's come here and let's begin. Double click here and let's make, for example, a title. This is just a comment. So we say RPL demo program. This is made by me, by Marco Walter, and today is 01 December 2023. All right. Then, for example, let's make something easy. Let's, for example, let's make a move to. Okay. In order to make a move to, I would like, for example, to move back the robot for the first thing, getting back to the begin point. The begin point, let's say that in my case, could be a 0, 0, 0, 0. In order to achieve this, I can come here in variable and let's create our first variable. Variables you can see are module, external, and routine. Module are the global variables. They can be seen by all the RPL program, also by subroutines. Routine are the local variables just seen by the current routine. And external are variables that are related to what is defined externally, so inside the rule and task. While you want to play with rule and task, you would like to play external. For example, inside the rule, we have some, this is the power, P tot, power total. In case I would like to see it, I must define it as public P tot, and in that case, I can come here in the external, press the green button in order to set a variable, and I can say it P tot. Okay, the system, okay, of course, now it will say that's not found because it will check the rule. Now I should first comment the rule and, I should first save, compile and reboot the system in order to have this public variable available also in the HMI. But since now I haven't done this, I am not allowed to do so. So remember, if you define them public in rule or in the task, you will be allowed to set them externally here, and so you will be allowed to read or write them, and so you may exchange the variables from the RPL environment to the R3 environment defined by the rule and the task here inside the project. So we are not using, but in case I would like to set some other variables, okay, here I can see other things. In case I need them, I should remember that they will be available only after loading and rebooting the rule and task with the public variables. Now, in the routine, let's make the variable we really want. And no, let's make it module, so maybe we will need it also inside some other subroutines. And we make a variable. This is the point home. The kind of variable will be a joint point. And the initial value, we can open parentheses and say 0, 0, 0, 0, then minus 90, and then 0. I play the minus 90 to avoid the singularity of axes 4 and 6. In this way, number 5 will make these minus 90 degrees, and so we will avoid that singularity. And this is home point. Very well. As I defined it as a point j, this is a joint point. So I'm writing inside joint position. Let's go here to code and let's say move joint to point joint. That's easy move. And here it already defined another point joint, which is the current position. I do not want it, so I come here in variables and I choose phome. The speed is so much, no, give me 300. The zone is fine. The zone means how much is the connecting radius between some subsequential moves. In this case, I don't want a connecting radius, but I want exactly to go to that point and finish the move in exactly that point without connecting to anything else in case there are other moves after this. So I set it fine. In case I would like some radius, I can see the millimeters of the various z of the zone. If I want other ones, I can define some of them in the variables. The same for the tool. Now let's say, okay, I choose the tool number 1 that I already defined as a 100 millimeters long tool on x-axis. And let's save. As I just said, if you want some other variables, here you can set the speed, you can see the v. All the speed are expressed in millimeters by second, and here the z, which are in millimeters for the connection radius, and here the speed of the tool. Now, okay, we will move joint to this point. Now let's imagine we would like to play a little with the robot, and let's make an easy program in which, okay, let's begin like this. So let's save. Let's take out the edit. Now we are in manual full. Okay, as I said before, the first time let's go in manual slow. Even if it's an easy program, let's do like this. Now let's play restart, and you can see a gray arrow arrived here at the first line of the main routine. Now we are allowed to start. I can press start and the robot is moving up. I can press the watch to see the robot, and I see the joints 0, 0, 0, minus 90, 0. As you can see, the J4 and J6 are not in the same geometrical axis, and so we are avoiding a singularity point. Here we can see the robot Cartesian points. Now, since the program is finished, of course, the arrow already finished all the lines, and so it's no more available. Now let's move the robot. I click, I go in Cartesian movement. Let's go in minus z, for example, and let's go, for example, in plus y of some value. Normally, while you play with this kind of motion, normally you would like to do some pick and place or painting or welding application, and so normally you would like to teach points. In this case, let's open the edit, let's come here, and let's say move, we can say move joint to a point Cartesian. That's not so interesting because it will make a joint movement, so from initial joint to final joint we will have no control of what we do. In case we would like a linear move, so from point 1 to point 2 to follow the line connecting them, we must use linear. And mcirc is making the circle between 3 points. Now, just because we go to the first point of our working path, let's go in joint to the point C. And here we can see this asterisk, we can double click and we can see these values. These values are defined in a point Cartesian. And as I said before, if I ask from here, I get inside again, you can see here from the watch of the robot that the values have been correctly read by the current position. Let's ask. Now let's move, for example, minus z again in order to do some kind of a square. And now let's move linear instead. And then let's move, for example, now we go in minus y. And let's go, now we are in positive y. Let's go, for example, in some negative like this. Now it's more than minus 100y. And let's move linear again. And now we go up. Let's almost go to the initial point according to the height. And let's also put linear. And finally, I can copy this line, paste, and let's change the move joint. Here I can go to movement and change this move joint with a move linear. And the point will remain the same. In this case, I will move it to the exactly point. The same as here, but not joint. I will move in a linear way. Now I don't want fine movements. Maybe here the first could be a fine movement, but all the other ones may make some connection. So let's take 50 millimeters, all right, and here again, let's move in 50 millimeters. And the last one, no, the last one is the end point, so I must respect it. And also this, yeah, also this should be 50. Okay, now let's save and let's play again. Let's go here, let's restart, and now let's play. We go up, and now we are going down. You can see that it's not a straight line, but it's some kind of generic curve, while now instead we are moving in a Cartesian way. And you can see that corners are not sharp, but they have this round, which is made by the connection angle of 50 millimeters. And so we have done this kind of motion. As you can see, after the program has been finished, I can move around. Here I can see the path I have made. Okay, now let's see something more. In case I would like to do just something, I can play also step by step. I can click here on continue and make step in or step over. In case I have some functions, I can use step in also to go inside and make a step by step movement also inside the function. Otherwise, a step over will just make one step, and if the next command is a function, all the function will be executed. Now let's just say step over, and let's see that, for example, I restart. I can press start, do the first. You can see here this picture of the robot with the red arrow. Now it's green because it's pointing here but not moving. If I press, it's red. Now I cannot press anything else, and now I can do other movements. While the arrow is red, it means that the robot is moving. While instead the arrow is green, it means I'm executing some kind of command without any motion. And now, okay, I will finish. But it's not all. Okay, that's finished, and you see the arrow exists no more because the program is finished. If I want, I just would like to play something, I may come on a single line and set PC. I should pay attention because I will directly press start and execute this line. In this case, As you can see, I have chosen the opposite angle, so I must be wise and check what line I'm really asking, because I can do something dangerous. But in case you are just debugging on your PC, you are not using a real robot, or you are not in a production environment, you can do that kind of things just to play a single line. Now, for example, I played line number 5. I do not care of line number 6, I will just say terminate. And for example, now I would like only to go to home. Okay, I will set PC here, and I can say step over and start. So, in this way, I will just request the robot to do only this. And now again, I will say I don't care of the rest of the program. Let's terminate and restart, so the cursor will come again to the initial line. That's mainly the key part of the RPL, so while you are moving, you will move joint, move linear, and after this maybe you will set some variable that will be shared in rules. So you will handle some I/O, you will start painting, stop painting, you will read some input, make some condition. And so now let's make another example, okay? So let's go to File and let's make a new program. Let's say new file, and this is demo RPL2. Okay, let's call it like this. Let's make it easy. And now again, let's make a variable. Let's make it, okay, just do it routine. And in the routine, I will say this is p home. And the p home is again the point joint, and the initial value is 0, 0, 0, 0, minus 90, 0. Remember the parentheses, otherwise the initial value will be not valid. And now, for example, let's also use a subroutine, so we can have something more. Let's make a repetition of some kind of shape, and together with this, let's also modify the points using some offset. Now, for example, let's create not routine, but let's make a module, so some global variable, and let's put here point Cartesian 1, and this is okay, is a variable. I can put constant, for example, or retain, which will keep memory. This is not integer, this is point C, visibility local. Okay, I can see also something public in the task or global, but we do not care. And here now let's begin with the Cartesian point. Let's choose an almost random point. Let's say 500, and let's make 100, and I think 300 will be good, and 0, and 180, and 0. Normally, okay, let's play. This is my PC1. Now let's go to code. First line, I always like to put a comment just to explain what's the program doing. This is demo, not path, this is sequence of steps RPL. Okay, and now, first of all, like always, I'd like to come here, say movement, move joint, and let's choose to go to P home at 300 speed, zone will be fine, and tool is 1. Click it, okay. And as a second move, let's choose a linear motion, and the point I want will be the PC1. That's just an example. So, okay, let's save. Let's see if the program is possible, because I just invented this PC1, and maybe something very terrible can happen. Let's restart and let's play. The first motion is doing, it's step over, so let's go continue. Let's press start, and now I'm going to that point. Okay, as we can see, now we are in manual slow, so again we are at 20%, and And remember, we are playing the dead man. So normally in the real TPU you will press by hand, and in case you don't want to keep pressing this, you can leave it and go to automatic mode. Of course, the dead man is a safety for manual mode. Anytime you release it or you make the double step of the button, it will lose the power. I talk about the double step because this kind of button has the first step, which will give power. The second step is a panic step, and so in case you press strong and you make the second step, you will cut again the power. That's some safety. So let's say normally if you want to play the system, you must go in automatic. The system will make you, if you are sure and if you want, to restart from the first line. Okay, yes. Now I must press power instead, and now I am allowed to start. And so here again I can modify the feed rate to 100%, I can press start, and here I have no need of the dead man. Remember, in case the project is not good, I will need to press the red button in case of emergency, or if I want, I can just press stop like this, and the robot will hold. Pressing start will make it continue its movement, so it's like a start and stop and hold the request. Now, okay, I have found this, I have made this motion. Now let's create some other points. For example, now we are in automatic, so let's take it out. In automatic, I'm not allowed to modify, so let's edit. Let's copy and paste. And that's PC2. And PC2, for example, will have, let's say, 200 here. No, sorry. I prefer to have 600 and 100. Okay, so I made plus 100. And now copy and paste. And here I will go in minus 100. Okay, and then copy, paste, and here the X will go to 500. All right. Now, let's take a look. Let's, for example, create a subroutine. Let's come here and make a new subroutine, and this is the move sequence. Here inside the move sequence, now I can choose and say go inside the move sequence. And here, for example, I can define the input parameters of this variable. Now, inside we can see the module variables, which are global, and here I can see input and output. Now in the input, let's put, for example, a variable which will be, the direction, so let's call it direct, and the direct is an integer, it's local, the initial value could be +1. Okay, and this is motion direction. All right, and together with this, let's put also a height, so let's put it here. A variable, let's say local height, and local height will be a real number. That's a variable, the initial value is 0, and this is local offset, local height offset. Okay. Now, the order of the input here is the order of the parameters we want to set in the main. I want this to be first, so let's cut and paste. So direct will now be 1, and local height will be second. And now let's go to the code of the motion sequence. So let's go again to the main. Let's copy this. Let's go to the move sequence and let's paste. Here, oh, yeah, for example, instead of this, Okay, let's paste, and then 1, 2, 3, and 4. And now we have PC1, PC2, and again I do not want fine. Would like to have some radius, so Z20. This is not fine, is Z20. And PC1 and PC2, so this is PC3, and that's Z20. And finally here we have PC4 and again Z20. Very well. And that's done. Now, for example, that's a begin. So let's go back to main, and here, instead of this, let's cut it, and let's just go here, press the new command, and here you can see some trigger, some interrupt, some other variables and commands. As I said before, you may read them, you may learn more about them reading the manual. Here we have movement, okay, you can see, and here the common part. In this case, I want a call. So let's call the subroutine, which is the move sequence. And as you can see now, my two inputs are requested. So the input one, now I have no variable, so I'm sorry. I need to make, okay, let's just say 0. Now let's just say 0, 0, because otherwise I will have some error. Okay, let's do like this, and let's begin. Now, of course, if I restart, the main will begin, will call the subsequence, the subroutine, and it will execute everything. Now let's go again to main. We are in manual slow. That's a good debug. Let's press the dead man and let's start. So I'm getting up. So now you have an easy demonstration of the difference between move joint and move cart. The joint is from initial point to end point, we don't know the direction. And the linear instead is exactly aligned. Now you can see we are moving and doing the 3 movement P1, P2, P3 and P4. This kind of pieces making 3 lines. Very well. Now let's come here, let's take out, let's make edit, and let's come here. Let's, for example, make some other variable, and let's play. I would like I is an integer, is a variable, the init value is 0, and the description is just for cycle counter. As you can easily understand, we will play it for a 4 cycle. And let's also put another variable, let's say it age, for example, which is a real variable. The begin value is, for example, 40. And here it will be the height step. All right. So I would like to make the same shape, and I would like every time to increase of some of 40 millimeters, for example. Now, I also need a direction. So let's make another variable. Let's make it, this is the direction of main. And this is description main direction variable. And the begin value will be +1. Excellent. Now, let's go again to the code, and here below let's cut this, and let's put a 4 cycle. From the variable I, which goes from 0 to, I don't know, let's say 10. Alright, I have no need to set the increment, because the increment will be automatically set to 1. If I want another step, I can just write it. And here let's paste the move sequence. Okay, the move sequence wants at first the direction, and so that's direction M. And the second is the height. The height will be I multiplied age. So the first time the offset will be 0, then 1, 2, 3, 4, 5 multiplied by the HH parameter. And of course, at the end of every move, we will need to change the sign to the direction, because if I do one square going left, then I will go up, and one square rectangle, let's say one other shape, right. So in this case, I need to say the direction will be again the direction multiplied, let's say, multiplied by a number, and the value will be -1. Now I hope, okay, this should be written in this way, and that should be enough. Now it's not enough, because inside the sequence I never used the height and also not even the direction. So let's go to the move sequence and let's take a look. We have direct and we have a local height. So we need to go to the code and check. First of all, we need the points with the offset. So the best way to play with RPL is to create some points as referred to the others, so these four are the main points, and every time inside the subroutine we would like to create some local points which will have the offset. So let's come to variables and let's, for example, come here in module, or just routine, which is better, and let's say inside the routine I want the local point C1, which will be a point Cartesian. Okay, and let's copy and paste, and okay, as we can see, they are just increasing their numbers. Very well. Now let's go to the code, and here at begin, let's put a comment. So let's make offset from global points of sequence, and now let's put a line here above, and let's say this is equal. So the point, let's say local point 1 will be a function, and so this is an offset of the main point. So let's go again to variable is PC1, and the offset is 0x, it will be 0y, and will be in Z, we will have local H. Excellent. Now of course we just copy, paste, paste and paste, and then set something else. Oh, sorry, not here. Okay, so 1 and 1, of course this is 2 and 2, and then 3 and 3, I say it's 3, and finally local point 4 and point Cartesian 4, 1, 2, 3 and 4, 1, 2, 3 and 4. Excellent. And now we check the direction, of course. So let's go here again and let's say if. Here in the common functions we find if the condition is if the direction is bigger or equal than 0, okay. If the direction is positive, let's cut and paste. Let's cut and paste. And okay, now they are PC and not all PC, so now I also need to modify them. PC1 is all PC1, and so on. Yeah, I know that this editor is not letting me to write columns or something like this, but that's a standard robot programming tool. Now we need the else. The else, you must go to the end if, and here below you can see the else button happening. Now let's open the else, let's cut this pointless, and here let's copy and paste. Let's copy number 3 and paste number 3. So as you can see in the direct order, now we will also put a little comment here, should be here, no, why here? Let's go here. So here, let's say this is direct way, and then copy and paste, and here we can say reverse way. All right, I always suggest to use comments to make your code easier to understand. Now that's just an easy program, but keep in mind that it's a good habit to always write comments. So I offset points from global sequence, copy and paste, and here I can say 2 local points plus 8. Okay, and so here we offset the points in Z. In direct way we move linear 1, 2, 3 and 4. In reverse way 4, 3, 2 and 1. That's good. Let's go again to the main, and in my opinion we have done. Let's save. Let's take out, oh, something, okay, it didn't work the first time. You can see here there is no asterisk. When there is an asterisk, it means the program is not saved. You can play, but it means it's not saved in the file inside your RPL. Remember that saving a program will save it inside the RPL folder of your controller. If now I do fdir /rpl/, oh, sorry, not F, I can see all of these programs. So demo RPL 2023 December 1st that I made before, and now the demo RPL 2 that I'm writing right now. Okay, now let's take out the edit. I already have the dead man, we can restart, and let's see what happens, and let's hope I made no mistake. Now let's go to number 1. Now this manual slow is 20%, so it's quite boring. I hope very soon we will move faster. Let's say now, for example, I just say, okay, very nice. Let's stop it. Let's go. No, I don't want to go to auto. Okay, yeah, let's go to auto. Terminate. Restart from the beginning of the universe. Okay, let's press the power and let's just go to 100%. Let's press power. No, I'm missing power. So, power. And now let's play. Okay, now let's go. Very nice. So you can see, thanks to this, I can do all of this kind of shape repeated more times together with some offset. Very interesting. Now, here below we can see some messages. So it could be something nice also to see a message. Let's see it. Now let's go again from automatic again. Let's go to edit. Let's put here and let's say new command should be, no, not movement, it should be other message. And here the text message will be value, and I should say here is moving, executing, step, and if I remember correctly, I can say %d, and here in the expression I can say I. It should be like this. Let's save. I'm not actually sure of this. Let's use the manual full so I can play the dead man. I can increase this, but later I will still be allowed to edit. Now let's take out the edit and let's start. Oh, sorry, restart, of course. Moving, and here executing, step 0, Step 1, okay, this percentage, this is pointless. So let's stop, terminate, restart, edit again, and let's go to main. Let's come here in this text and just take it out. Step, space. All right. And save, now edit, restart, and play. Okay, executing step 0. Now executing 1, 2, excellent. So we can see also the step and we can get some debug information. In case your program has some problem, remember that you can stop at any point, come here, and inside the watch you can go to see the line watch. Here in the line watch you can take a look at all the variables. So for example, I can see the current value of all PC2, that now is that kind of value. I can see the Z20, I can see all the parameters I have right now. And if I click on the robot, I can see on the joint, Cartesian and reference system position of my robot. Now let's keep playing our code. 6, 7, 8, 9, and finally it's 10. Yeah, as you can see, this 4 step is going from 0 to 10, so we also execute number 10. It's not like the other steps where the ending part is not included. In this case, it is. Okay, this was an interesting demo of the RPL I wanted to show to you. So you have now the knowledge of how to write variables, the difference between routine and modules, because as you can see, the local points are not here in the main, but they are just defined here in the move sequence. In this way, we are not putting too much stuff here in the main code. And of course, using subroutines is a clever way to give some repeated code inside, just doing some offset to points and just move. And remember that inside subroutines you can define inputs and outputs in order to communicate between the functions from upper level to lower level. You can write messages, you can make demo, as we have seen in the prior program. In case you want to edit, here below you can just teach points, so you move the robot just like this. Now it's Cartesian, so let's go again to jog. You can just move the robot like this, reach the point you really want to use, and you can just edit, and inside edit you can say move joint to the current point C, move joint to the current point joint, or move circular or move linear. In this way, if you just need to make some steps like a pick and place motion, it will be really fast to develop. You will just move, then set through to some parameter to close the tool, then move to the ending point, open your claw or your tool, and then move away, and you are ready to start again. In case you want to execute more times the same command, you can put, remember, you can also put some labels. They should be here in common, yeah, label. You can create a label that is just a string, and then you can use a goto command in order to go again to that line. And so you can make infinite programs, or you can use some if in order to check if you have the condition to execute again, or in case to return and finish. I think that's everything you need to begin playing with RPL.